student, already what we have discussed the estimation of sulfate and estimation of fluoride. So especially we are going to estimation of all other things. So all other things includes that is dissolved salts. So we can go into estimate. Otherwise totally we can TDS, total dissolved salt, we can go into estimate called as that is hardness. So in this case the next topic is sewage. So in that sewage already you know it. So anything of unwanted things are there, without removing off we can use it as we cannot use it for any purposes, we can call it as sewage. A dilute liquid aqueous, that is cloudy dilute liquid aqueous solution is called as sewage, or discharging or discarding of after primary use of the water. It is a dirtiness is contains and it is not worthiness or unwanted things are there, we can call it as sewage. Why it is happened this sewage? So we are using up water for all our purposes. After using up the water once, so it contains it adding of unwanted things into the water, it becomes automatically, we can call it as impure water, or water is polluted, or we can call it as sewage. That is towards of one first point is point of polluted source. Non-points also we can do it, it is a very low, is also percentage is very low, and it can automatically percolating of the water, so that at the time finally it can, water is only percolated, all other dissolved salts and undissolved salts are accumulated in the earth surface, in the earth ground or in the earth crust. So that is the things. But in first point we have lot of 90-95% of water we made polluted. So we can suppose we have not to reduce it, not possible to reduce also. Instead of that, what we can do, only treatment of water, that is removing of waste things, that we can call it as a sewage treatment. So without we have done this, we can connect it to the any of this pure water, immediately the pure water source become impure. That is also a sewage. So far, only way is treatment of sewage. For this treatment of sewage, not only the one stage, it contains, it is in the three stages. The first stage is we call it as primary stage, or also call it as physical and chemical stage. Second stage is we can call it as a secondary treatment, so that is also called it as a biological treatment. The third stage is we can call it as a tertiary treatment or a chemical treatment. All these treatment is completed, followed by we can taking into as any volumes of sewage water, it is completely transferred. It is completely modified into a purest water. Purest water is distilled water. Pure water is rain water. We can automatically, we can changing into that. We can remove completely all types of the impurities from the water. Automatically it is, we can call it as a soft water or drinking water or potable water. So that is using for all purposes. So in this treatment of sewage, first stage is primary treatment or physical or chemical treatment in that. So it is little bit 3-4 small stages are there. First we can, the water is screening it, followed by skimming, followed by filter, followed by coagulation, followed by it is sedimentation. All these things we can do it, all this process, the primary stages of treatment is over. The removing of the all suspended particles, whether it is a twig or a leaf or any other organic materials, it should not dissolve in the water. Whether it is a glass piece, plastic, anything is settled down, it is not floating, it changes of colors also. So whatever it is, so it is not floating, it is settled down at the bottom, that we can call it all suspended large particles or coarse impurities, we can remove by screening or sieving, or we can using of any other methods of this net type of sieves, we can remove it. Afterwards, to remove this any oils or greases passing into the one more container, the tank, we can call it as a skimming tank. In that, fill the already removing of suspended particles, coarse suspended removed water is passed, then passing of air compressor. Through compressor, passing of the air, at the time of action of this compressing gas is passed towards the down, the whatever it contains, the greasy and oil substances react with that pressure, that oil substances become forming into a froth. That froth is floating on the surface. Immediately by skimming method we can remove. So we have removed the grease and oils, and the large coarse suspended particles also we can remove. The next is it can subject it to the filtering. In that filtering, it of course it is made out of graded gravels also, sand filter beds also we can prepare. In pouring on that the water, whatever is already screened and skimmed water is poured, then it is whatever is organic impurities, or that is also look like of non-degradable, as well as any other impurities are there, completely filtered. So we can collect the filtrate, then we can apply the coagulants. That apply the coagulants, the process of coagulation as a taken place. What is in that coagulation? You can applying of ferrous sulfates as a and alum. So these are coagulants. Whatever this, it is not dissolved. It is floating in the water, that impurities under the size of 1 to 100 nanometer. It is after we can applying of ferrous hydroxides or ferrous sulfate, ferrous chlorides, or including of alum, automatically all these colloid particles are together and forming into as a precipitate. When it is precipitate, then you can pour into the sedimentation tank. At the time of the sedimentation, it is the process of removing of already precipitated or suspended particles settled at the bottom. We can remove easily that water. We can call it as a primary treated water. Everything is, this is over, then it is we can subject to the secondary treatment or biological treatment. In this biological treatment, why do we use it as? We are applying the microbes. In that microbes are bacteria, fungus, and of course of these things we can provide this vigorous amount of excess amount of oxygen. Aerobic respiration takes place. At the time of organic impurities are there that can be oxidized by these microbes, and as well as vigorous containing of oxygen. If it is less of the oxygen or no oxygen, anaerobic respiration takes place. Instead of the end products of the respiration, aerobic respiration end products are carbon dioxide and water. If you not supplied the air, anaerobic respiration takes place. End products are alcohol and carbon dioxide as formed. So this alcohol is one of the, again it is impurities. Avoid to that. In the secondary treatment or biological treatment, we can, the primary treated water is transferred into the sedimentation sac with supplying of oxygen, and it is give the space for to spraying of the microbes, that is bacteria. So at the time 3 to 4 days or 5 days under the room temperature, vigorous passing of oxygen, we sprayed over the microbes, that is with presence of oxygen, oxidation takes place. End products are carbon dioxide and water. Carbon dioxide is effluent is coming out from the container. This is what is the definition for BOD as it is continued. Already you know about of this definition for BOD is the amount of oxygen is required for complete oxidation of organic impurities by microorganisms under the room temperature up to 4 or 5 days. We can call it as BOD. This is that has taken place with presence of microbes, so we can call it as a biological treatment. Also we can call it as activated sludge. If we not activate this sludge by microorganisms, it is only this at the time of this slimy and non-adherent is settled at the bottom. When you can apply pressuring of oxygen at the time completely it is oxidized. The almost all whatever the parts of degradable organic impurities that is completely oxidized, remaining is settled at the bottom. So this is the secondary treatment or activated sludge treatment. You can collect the supernatant. What about the base or residues? You can using as a manure. The supernatant whatever you can collect it, you can apply the chlorination. You can apply the bleaching powder. Whatever the bacteria are remaining in the water, that can be killed by this chlorination. That you can then merge it into the running water bodies also, no problem. From the primary first and second things, we can 90 to 95% of water purification takes place. But for the drinking purposes, it requires the tertiary treatment. This tertiary treatment also called as a chemical treatment. From this already secondary treatment, primary treatment is over. In the tertiary treatment, treated with the lime. When treated with lime, whatever the phosphates are there, react with this lime, forming into as calcium phosphate. This is also the precipitate reaction, settled and settled at the bottom. You can filter it. Take this filtrate, removing the residues. That water is treated with the sulfides. Whether it is sulfides, whatever the metals is metals oxides, metal sulfide dissolved, immediately metal sulfides has formed. Filter it and take the filtrate. Followed by it can treated with the activated charcoal. Whatever the remaining very small minute non-degradable organic impurities are there, react with them and also it can form the precipitate. We can filter it. Followed by the last is colloidal particles. Supposed to be this, any traces are there, we can apply the alum, ferrous sulfate, ferrous chloride. Immediately any of these colloidal particles is coagulated and we can send them pass on to the sedimentation tanks, take the supernatant. So this is the completely free from all types of dissolved impurities and undissolved and suspension also. What is the next is again you can apply the chlorination because any minute bacteria are present, you can remove it. Followed by you can passing to the ozonation. So before that ozonations also you can apply any of these colloidals also it is over. In that ozonation the cold oxygen is reacted with this dry oxygen forming into as ozone. Ozone is dissociated into nascent oxygen as formed. That nascent oxygen again it is killed in the bacteria whatever it is there. Of course almost all types of impurities as cleared. Again if you want you can distill it. So at the time of 100 degrees centigrade almost all the things as a cleared. That water we can call it as a purest water. Distilled water is purest water. You can taking the one and it is a sewage. We can everything all the three process is over. After the ozonation, distillation takes place. This is purest water. It is tasteless, odorless, everything is less. That is purest H2O. If you want, you can add the minerals. It become a mineral water. If we not added the minerals, that is we can call it as a purest water. We can get it. This is the process of treatment of sewage. As the same way, if any other methods are also there treating of water. Of course, it is there. Ion exchange method is there. Reverse osmosis is there, including of other methods. Electrodialysis also there. So far, in all these things, university has prescribed desalination or softening of water by ion exchange method. Whenever we are using the term of ion, there are two types of ions. What are those? One is cations, another one is anions. When we are using of these two terms, one is cation and anion, So we require the cation chamber and require the anion chamber. Before we can go into that, what is this ion exchange method for this softening of water? Removing of the hardness and removing of dissolved salt from the sewage, salt from the hard water, we can call it as softening of water. What is that in this softening of soft water and hard water? So any of the water does not produce the leather with the soap is hard water because of hardness. This there. Whichever the water is produced the leather with the scum, so or leather with the soap, we can call it as soft water. Soft water means it doesn't contain the impurities. Removing of these impurities from the water, we can call it as soft water. The process is softening. So this softening is by ions. Two types of the ions. First is cation chamber. Another one is anion chamber. Inside it is formed some gravel graded and sand filter bed we have prepared. So in both cation chamber and anion chamber, so both it requires these sand bed filters and gravel graded also we have fixed it. About to that we have a supplying of one chamber we can call it as cation resin, another chamber we can call it as anion resin, we can apply it. So that is also you can fill it. So afterwards in the sidewise towards of cation exchanger, the cation resin again regenerate, we can fixing to the any of the concentrated mineral acids. As the same way, we can fixing up one alkaline or bases connected chamber is also this anion chamber. So this is the experiment to set it up. So afterwards, you can taking of any water, you can pour into the first chamber, that is a cation exchanging chamber. Name itself indicating as whatever the cations are there. So calcium carbonate, magnesium sulfate, sodium chloride, whatever it is, the single salts are there. So immediately, so that is denoted by RH plus. So it is reacted with this cations, that is Ca and magnesium, sodium, any others also there, potassium, immediately react with that, forming into as RH plus this calcium carbonate RCa plus as formed. So like that, cations are attached towards of this resin. So far we can call it as cation exchange. What is there in the remaining? That H plus and carbonates, that's H plus and sulfates, H plus and chlorines, HCl, carbonates and these compounds as formed. Afterwards it is passing through gravel sand bed. So it is passed automatically, then it is passed on to the anion exchanger. Anion exchanger also containing anion resin, that is R-OH minus. R-OH minus completely it is there. Whether it is already it is H2CO3, HCl, H2SO4, whatever it is, acids are formed. Immediately this H plus and OH minus as reacted, and this OH minus in this R is reacted with this CO3 sulfate and chlorine, any other anions are there, it is attached to that. Remaining what is there, H2O is passing and we have collected. So all types of cations is exchanging in the cation exchanger. All types of the anions are exchanging in the anion chamber. So finally, both the ions are, we can filter it, so we can using for our primary purposes also, drinking purposes also, for all purposes also. So how do we, it is always we can go into changing of this cation resin and anion resin? No need, because the cation resin is containing R2Ca plus, but for this R2 Mg2 plus, R2 sodium R sodium plus. To this you can add HCl. So immediately, so H is attached to this RCa plus plus. Ca is removed and HCl is CaCl2 as formed. All types of the salts as formed. That what is already this cation exchanging cation as given, that is again getting by this acid. So far we can call it as acid generation. Acid chamber is connected to this regeneration of anions. As the same way, we can connect it to the cation for anodes, that is cation anodes anion exchangers. So in that, so that is a sodium hydroxide. Only you can fill the sodium hydroxide concentrated. So the hydroxide is react with the RCl or sulfate or carbonate. Immediately that OH is attached to the R dash OH. Everything is R dash OH. The sodium chloride is there. Sodium chloride is formed. Sulfate is there. Sodium sulfate is formed. Nitrate is there. Sodium nitrate is formed. So chlorine is there. Sodium chloride has formed. So that is formed all salts in the plates. We can remove those plates. Again it is ready for filtering of all the cations and anions from the water. So that is the method to exchanging of removing of cation and anion. This is one of the methods also, cheapest also, easiest also. What the problem is there in any of these volatile organic compounds are there, it is not possible to remove. So for it is afterwards, if you want to use it, you can chlorinate it, then you can distill, then you can ozonate it, you can do it automatically. You can it is free from all types of impurities. You can using for drinking purposes also. So this is the softening of water by ion exchange method. The last method is there. One is the desalination of water. What is the desalination? Desalination. Salination means adding of the salt. Desalination means removing of the salt. Removing of the salt from seawater. That is salt water. Only salty water. All types of salts are there. You can remove. No other impurities are. Of course, it is using for drinking. Any other impurities are there. You can subject it towards ozonation, chlorination. Then it is treated with acids also. We can remove all types of these impurities. But in reverse osmosis, already you know it about of this. It is not only reverse osmosis, it is the distillation, reverse osmosis and electrodialysis. All these we can examples of desalinations of water. Removing of this. That is, one is you can already heard the term is osmosis. What do you know about the osmosis? Reverse of the diffusion. What is diffusion? The movement of the molecules from the higher regions of the concentration to the region of lower concentration. This is example for both gases and liquids also. As they say, any room freshener you can press it at any one of the corner of the door. Automatically you can close it the door within a minute. That odor it is completely filled the room because of the movement of the molecules from region of higher concentration to the region of lower concentration. We can call it as a diffusion. The osmosis reverse to that. What is that? The movement of the molecules from the region of lower concentration to the region of the higher concentration through the semi-permeable membrane. We can call it as osmosis. Here if you want, you can take it one boiled potato, fill the sodium chloride aerated water into that boiled places. You can keep it into the 100% of pure water. Immediately the water molecules moving from the pure water enter this boiled potato and diluted this whatever the concentrated sodium chloride is there. It is diluted until it gets the equilibrium. That indicates movement of the molecules from the region of lower concentration to the region of higher concentration. We call it as osmosis. Make it reverse. Make it reverse is we can call it as a reverse osmosis. Make the reverse of the natural osmosis. We can call it as a reverse osmosis. For this we can require one tank and separation between this pure water and desalined water and desalined water. Any one of the acetate, cellulose or any one of this polythene it is making into as fabricated and fixed into the chamber. To one side you can push, you can add the salt water. At the time, any small quantities of purest water is there, the movement of the water molecules from the region of lower concentration towards the region of higher concentration, at the time we no need to get the purest water. What to do this? Same you can set up the experiment. At the time you can apply the pressure. You can apply the pressure. At the time the purest water is passing from region of higher concentration towards the region of lower concentration. That is, purest water is moving from salt water towards the pure chamber, purest chamber column through this semi-permeable membrane until you can continue the pressure. So it is pressure is more than the osmotic pressure, you can apply reverse osmosis takes place. Lesser to the osmotic pressure, only osmosis taken place. So far, it is also very easy. We can get it also, easily set up also. To any type of the salts are there, cannot be transferred through this cellulose or acetate or any other fabricated of selectively permeable this membrane. Only water is possible to passing, so you can get it the purest water. If you are having any of the doubts, you conduct applying the ozonation, chlorination, distillation, then you will drink it for 0 ppm or drinking water. You can use for all the purposes. So for any type of the water we can get it also after treated sewage water, after treated any of the salt water, we can making to fit for drinking water. We can call it as desalinations of water, and exchanging of water, treatment of sewage. So treatment of water we can get it as a purest water, potable water. It can use for all purposes. So that is treatment of water. Everything is over. The water chemistry as a completed of the second part of a fourth module.